Hello, everybody. Welcome to this webinar on advanced topics, permutation, combination, and probability. With my experience, I've talked to so many students till now. This is a pain point, a common pain point. People say, "I like most of quant. I understand most of it, but this is one bit that always puzzles me." So our goal today will be to unpuzzle you, to make you comfortable with this. Stay tight till the end, and you will see the improvement. So, as I said, agenda will be solving permutation, combination, and probability questions using a structured approach. So, the approach is what we stress heavily. It's not just about getting questions right, it's about getting them right the right way. Well, let me introduce myself. I am Shweta Koshija from EGMAT, and today we have Ashutosh, another EGMAT quant expert, supporting us. With this, let's get started. All right. No, you're not early, you're just on time. All right, just 1 second. Please, everybody, confirm if you can see the screen. All right. Hi, Sudeep. Hi, everybody. Just trying to move this. Ashutosh, if you have the PPT, could you also move to the next screen? I think there's some problem with this. Yes, thank you, Jaskirat, for confirming that. Just give me 1 second. Ashutosh, tell me if you can share the PPT, please. I'm facing some problems with the navigation. Hold tight, everybody. Just a few more seconds. We'll get started. I'm sure you can all see my cursor moving. I can see it moving. Ashutosh, could you please confirm?
Hi Shweta, your screen share has stopped. Can you share your screen again, please?
Yes, I'm just waiting for Ashutosh to share the screen.
Oh,
Yes, just give me 2 minutes. All right. Okay. Everybody can see the screen now. Sorry for the little glitch. Please confirm one more time if every Oh, Satya Vrata, you were there in the earlier session. Repeating itself, but hopefully it's not gonna be that long now. Last time it was a good 10 minutes that we could not control this. I don't know why this happens. But yes, we're set in time. Uh thank you everybody. All right. So here let's start talking about this. Purpose of the session. Well, the purpose is to help you understand the right strategies to solving these questions, these advanced topics. The key to acing the GMAT, is not just about doing tens of thousands of questions. It's about, first of all, solidifying your concepts, then using a proper approach to solve them. Okay, let's see what's next. Ashutosh, I would request you to keep flipping. As you see, I'm done with one piece. All right. This is very important. Everybody pay very close attention to this. The flow of the session. So you have to know how the session is going to progress. What is it that we're going to do first? What next? So we'll start with the warm up. The warm up is simple questions, 500, 600 level questions, which are there to warm us up. So these are going to be permutation combination questions. Then through the solutions of these five questions, we are going to review the concepts. As I said, in geometry, people who are coming again, it's not going to be on a platter. You'll see concepts coming in through questions. After that, as you see here, will be sprint one, which will be the first time you practice what you learned. So in sprint one, you are going to have 600 to 700 level questions. So you'll have three questions there, 600 to 700. Then sprint two, again, you'll have three more questions, this time 700 plus level. So you can see how we're gradually raising the bar, raising the difficulty level of the questions, and you should feel equally comfortable throughout the session. That's our goal. You should feel as comfortable with the 500s as with the 700s. Feedback and takeaways will be discussed after each sprint. Feedback is really, what do you take away from that set of questions? What is it that you should remember as you go to the next sprint? Takeaways, feedback. Faltering point discussion is throughout. Now that's very important. After analyzing so many people's performances, we know where people generally falter. We know how the exam sets the traps. So there we will point out those common faltering points to you, and you will then, since you'll know the faltering points already, whenever you see a situation arise for the same thing again, you will not repeat them again. So this is how the session is going to progress. I hope I made myself very clear about how this is going to work. Now with this, let's move ahead. Let's see what we have next. Warm up section, as I said, you're going to have basic questions on permutation and combination. Why not probability here? Let me tell you one thing before we even begin. Permutation combination is like step one. Probability is then step two. So if somebody knows permutation combination, then the transition to probability will be really smooth. So that is why the base, the foundation, had to be set with the foundational topic. So it had to be permutation combination. I'll tell you about your current level of conceptual understanding based on how you as a group perform on a certain question. The solutions will be discussed, yes, but it would not be too thorough because these are simple questions. It's about giving you the concepts, giving you the tools to help you solve questions in the sprints that come later. All right, this is our warm up introduction. This is what you have. Instructions, you're going to have five questions, not six, 500 to 600 level. Very important rule here. That's why it's written in red. You will be given polls to answer your questions. Why can't you just comment? Because we don't want one person's response to impact another person's response. It happens. I am marking B, I'm leaning towards B, and then I see three people mark C. So I start doubting myself. Is it C? Or am I wrong? Are they wrong? Generally, we tend to feel that the majority is right. We don't want to influence anybody. Yes, we're all studying here as a group, but we want to give everybody that individual chance of doing the questions. So here we will solve each question after you attempt them. Time tentatively is 5 minutes for five questions. But again, we will decide the pace based on how you as a group respond to it. So if we feel that, see, there are 200 people and we already have responses from 170 or so, we will start discussing the solutions. With this, we are done with the instructions for the warm-up section. So I hope you're all excited to begin this journey with warm-up questions. Here, what will happen is you will see the first question, the link to the first question in the comment box. You can see the question already here on your screen as well, but no answers here in the comments. Use the link, poll your answers, and come back. you can all probably read in the comments as well, the accuracy for this is 36%. Now, for a warm up question, that accuracy is pretty low. And you know what? This tells me again about what I believed, that it's the fear of these advanced topics. It's this lack of the very basic conceptual understanding of these that takes away the chance that we ever solve the hard questions. So this makes it all the more important that we build the foundations correctly. Listen to this question. What are we saying? In how many ways can we form a three-letter password using the letters from the set A, B, C, D, E, F? So you have six letters and you have to choose just three. That means any three of them could be there, and nothing in the question says that you cannot repeat the letters. So I saw a comment. Sudhanshu asked, can we use a character again? If a question does not specify that repetition is not allowed, it is allowed. So here, since it did not say anything like that, you are allowed to repeat letters. But we're not totally free here. It's not as if I can take six letters for the first spot, then six letters for the second spot, and then six for the third. In that case, my answer would have been 6 times 6 times 6. Why am I multiplying? Here's a golden rule I'm going to give you. Whenever you solve a question, just say it out. So, what I'm saying is the number of ways of selecting the first letter is 6, and then ways of selecting the second one, 6, and then 6 again. So, that and that I said stands for multiplication. But here I'm not that free. My question wants the last letter to be a vowel. Now, how many do I have? Let's look at the set carefully. A, B, C, D, E, F. Let's see the vowels. Let's hit next and we will see that there are two vowels here, A and E, which means this last letter that I have to choose will have just two choices. So if I write down the possibilities, it's going to be 6 times 6 times 6, as you'll see here on the screen. 6 choices for the first letter, because you can take any one. 6 choices again for the second letter, but 2 choices for the third letter. And that I said in between, that got converted mathematically into multiplication. So it's very important you say it out, because if you don't say it, you will not hear those ands. The question does not tell you what you have to do. It's these many choices for place one, and then that place is filled. These many choices for place two, that place is filled. Now these many choices for place three. So when things are going in succession, that you do one thing and then you do the next thing and then the next thing, you multiply. So as you see, the answer here is 72, which is option E. I hope the 64% of us that got this question wrong have now understood what is to be done. So what is the rule you're taking away? Let's hit next. You'll see the rules here. So the principle we're essentially using, Ashutosh, please. The principle we're really using here is multiplication of events, simple counting. Simple counting just means you count the possibilities for every place and then you're multiplying because they're having in succession. Rahul says, what would be the answer if repetition was not allowed? That's a good question. That's how you should really think. Go that deep. In that case, the first letter still has 6 choices. The second one would just have 5 choices. I'm sure till there. But the third letter, which has to be a vowel, now it's very important that I think about, has that vowel already been used in the first two letters? So there'll be two cases there. So that is a little more detailed, a little more intricate than what we have right now. So we will come to things like those when you think about what happens if there are multiple cases. For now, I hope everybody is charged up for warm up question number 2. The link will be up here in no time. Good luck, attempt that. I'll see you back with the solutions. The link is already in the comment box. Please use that link, it's already there. Please ignore the second link that just popped up. You just have to click the first one where it says warm up 2, question number 2. It is here as well, yes, but find it in the link, please. All right, we have the accuracy here. This is promising. 82% of you got this correct. So very happy about this. So this is probably that you already know. It's more difficult when you had to choose letters and all. Let's read this together to make everything 80% comfortable as well. So you have a junior class, class A. In junior school, there are two classes, class A and B. Class A has 6 boys, 4 girls. Class B has 8 boys, 7 girls. And how many ways can a teacher select exactly one student from each class to form a team of one boy, one girl? As you see here in the very first step, how can you choose one boy, one girl? Well, that one girl could come from A, boy from B, or the girl could come from B and boy from A. That's exactly what you see here. Case 1 is A boy. That means the boy is coming from class A, and B girl means the girl is coming from class B. Similarly, you have case 2. Now, since there are two cases that we have to deal with here, how do we find the probability? Let's see. So if I am to find the probability of case 1, which is when I have A, the boy coming from A and the girl coming from B, see how we'll do this. Well, you have how many boys in class A again? You have 6 boys. Ashutosh, please hit next so we can see the next step. So we have 6 boys in class A and we have to select one from them. See how it's written 6C1. C, which is actually C for combination. Combinations are used whenever we are selecting stuff. There's a big difference between combination and permutation that you have to absolutely understand. Permutation is when you're not just interested in selecting stuff, you want to select it and arrange it. That means the order is important. But in combination, you don't care about the order, you just care about what is it that you have selected. So we use C for combination when it's just selection. Now, here in my case, anyway, it's just one person. Order cannot matter when the elements, that the number of elements is just one. You at least have to have two things, right? Say you have people A and B, then the orders could be AB, BA. But when it's just one person A, there's nothing to do with orders. So here you have 6C1, choose one boy from 6, and multiplication. And choose one girl from class B. So class B had a total of 7 girls. So that is why we've written 7C1, which means choose one girl from 7. Then you have this or. You've not seen what or is yet. You know what and is, but what is or? So for or, what you do is you have another mathematical tool. It's not multiplication, it is addition. So we will add the second case as you see here, which is what now? Girl from A. So A had 4 girls. So it's 4C1, and boy from B. So boys are 8, so it's 8C1. I hope you are very clear about how or and are working. When it's and, I'm multiplying. When it's or, I'm adding. There's something deeper you are going to learn a little while later about or. But for now, this is all you have to take care of. Then let's see the calculations. You just solve this, you will get 6 times 8 plus 4 times 8. So 6 times 7, I'm sorry. The calculation should give you 74. Now, we had Amreen who posted the answer in the comments. Thankfully, that answer was wrong, but Amreen, you could have influenced other people. So, as again, the rules, no answers to be posted in the comments. Use the polls to give your answers. We'll be able to understand you as a group much better. I hope everybody is absolutely clear about this one. All of you are ready for warm up question number 3. The link will be up here in seconds. Good luck, everyone. The results are absolutely stunning. We have 100% accuracy here. This makes me very happy. So I know I don't have to spend very long on discussing this question, but still, let's go through it quickly. In a toss of 3 coins, what's the probability of getting at least one head? So the core idea we're trying to give you through this question is that you don't always have to start finding the one thing that's given. At least one head really means one head, or 2 heads, or 3 heads. So it's 3 events you'll have to take care of with their ors in between. That means you'll have to add each of them once you get them. A quicker way is just do the opposite. Find the probability of the non-event, which is the probability of getting no heads. Somebody says, I want at least one. What's the opposite? I'll give you nothing. just nothing. So this case, going to the non-event helps us. And the rule, as you see, probability of an event is 1 minus probability of non-event. So in our case, I have a total of 8 events, right? When you write down the sample space for all the possible outcomes that there are, there'll be 8. From those, the number of ways where there is no heads at all, it's TTT. 1. So our case, the probability of the non-event is 1 by 8. Therefore, the probability of the event that you wanted is 1 minus 1 by 8, 7 by 8. Look at the rule here. Consider all cases in the events. If you directly do the at least one head thing, you'll have to consider all 3 of them. But of course, I'm sorry, quicker was to go the opposite route and get the answer. So very nice. I can see everybody is charged up, 100% accurate here. Let's go to warm up question number 4. The link will be up here in seconds. Good luck again. All right, you have the results here. We have 84% accuracy. Let's see. A number is randomly selected from the first 48 natural numbers. Natural numbers are what? 1, 2, 3, 4, and so on. What is the probability that this number is divisible by both 3 and 5? So as you see here, numbers that are divisible by both 3 and 5 are also divisible by their LCM, which is the least common multiple. In our case, the LCM happens to be 15. So you're looking for the numbers that are divisible by 15. Or in simple words, you're looking for the multiples of 15. Now, in the numbers that we are working with, the first 48 natural numbers, what are the multiples of 15? You have 15, 30, 45. So you have 3 numbers in total that are multiples of 15. So the probability would be 3 over 48. So it's your favorable numbers, the numbers that you're looking for, over the total number of numbers that you have. So 3 over 48, which is 1 by 16. I hope the 16% of you that got this wrong is now absolutely sure about this. With this, we're ready for the last warm up question, number 5. The link will be up here. Good luck. All right, the results here are again change a big flip. We have 40% accuracy this time. So 60% of you did not get this. Now that tells me we have to take this slow. A number is randomly selected from the first 48 natural numbers. It's the same situation, but we have to find the probability that this number is divisible by 3 or 5. Now, here, if you just followed that or is plus, you will make a mistake. Let's see why. You are looking for those numbers that are divisible by 3 or 5. What does that mean? It means either that number is a multiple of 3 or it's a multiple of 5 or both. Now, here, probability number divisible by 3 plus number divisible by 5. If you just wrote the first two things, you'll go wrong. Why? Because you double counted the numbers that are divisible by both. When you count multiples of 3, even then you count 15, 30, 45. When you count multiples of 5, even then you count 15, 30, 45. So you have counted the same numbers twice. This is what I was saying. There's a little bit more to the OR that we're doing, and it's this. There's a risk in OR of double counting. So you don't have to just remember when this happens, when this doesn't happen. You have to think every time, okay, these are the two things that I'm working using my OR. Is there any repetition between them? If yes, you have to subtract that. So that is exactly what the formula here says. You have to subtract that. Let's see now what each of these values are. So numbers divisible by 3, first of all. What are the multiples of 3 in this entire range of numbers? You will see it's 3, 6, 9, all the way till 48. You have 16 such numbers. Then for those divisible by 5, 5, 10 till 45, you have 9 such numbers. Double counted ones are the ones you saw in the previous question, the ones of 15. So there are 3 such numbers. So overall, how many numbers are you looking for? You're looking for 16 plus 9 minus 3, right? So what does that become? This is 22 such numbers out of a total set of what? 48 numbers. So your probability is 22 over 48, 11 by 24. I hope everybody here sees the mistake if they fell for that little trap and just added 16 and 9. With this, we are done with the warm-up section. Let's see what's next here. In terms of the feedback, you have to make sure here's the formula for you. A or B is probability of A plus B minus both. Overall feedback, well, make sure you have 200% clarity of your concepts. If even a little confusion is still in your minds, go through the concepts one more time, spend more time with this. You know why? Because the GMAT will actually test a higher level application of this. This is not the level you're going to stay at, but this is what you need to go to that next level. It's the ABCs before you go to your bat and cat and mat, or even more difficult words. So this you have to be absolutely clear about. This is our feedback from the warm up. Let's see next here, Ashutosh, is time for sprint one. As I said, this is the first practice you're going to give yourself. Yes, you've been doing questions in the warm up also, but sprints will use the concepts we learned from the warm up. So when I was explaining warm up questions to you, I took nothing for granted. I did not assume that you knew anything beforehand. But the sprints assume, or they're based on the principle that you're coming with some knowledge from the warm up. So use that knowledge, get ready for the instructions first, and then we shall give you the link for the first question. Let's see. So you will have 3 questions here. As I said earlier, this is 600 to 700 level. Rules stay the same. You only mark in the polls. Time approximately for each question would be 2 minutes, which is GMAT standards. But again, we will decide according to how you work. So Zakaria says, trapped. Yes, that's the word. GMAT loves to trap you, and we love to untrap you. You have to take the tools that you learn today. Everything that you find about yourself, oh, I tend to fall into this trap. Take that with you, make a note of it, and never repeat that again. With this, let's have the first link, warm up, sprint one, question one. Good luck, everyone. All right, we have the accuracy here. Before I start discussing, thank you, Sudhanshu, for that sweet compliment. We have 74% accuracy this time. So 26% of you got this wrong. So my goal would be to get everybody on the same page. Let's get started. So there are 5 red and 4 blue balls in basket A. There's basket 1. And there's a total of 16 balls in basket B. No information about the color of those balls whatsoever. One ball is randomly picked from each basket. To understand properly what randomly really means, just think about it that your eyes are closed and you're picking one ball out of it. So you don't know what is coming out. It's totally random. One ball from each basket. The probability of both the balls being blue is 1 by 4. So the chances, the probability that the one ball that you picked from here and the one ball that you picked from here, both of them came blue is 1/4. How many blue balls are there in the second basket? Interesting question. So we don't know the composition of this second basket, but we already know the chances of drawing 2 blue balls. So let's see how we approach this. So there are 9 balls in A, as I said, you 5 and 4, and 16 total in basket B. Just suppose that the number of blue balls in basket B, that the number of blue balls, yes, is X. Then how many will be the other color, whatever it is? I just know not blue. I cannot say red. It could be anything. Those are 16 minus X, just about anything. Now, probability both are blue means what? Break it down, say it out. It'll be first blue and second blue. There came my and. And and means multiplication. So, what is the probability that the first one is blue and the second one is blue? You see the multiplication between them. Now, I can easily work with basket A. I know the exact composition. So, here, let's see, you have 4 out of 9. You have 4 red balls and 4 blue balls and 9 in total. So, 4 over 9. While for the other basket, I don't know the composition, but it's x over 16. And this multiplication, this product has to give me 1 by 4. That I already know. So now it's a simple equation to solve. I'm sure everybody can solve that. This is not why P&C and probability are difficult. You solve this and you get x equal to 9. So you have 9 blue balls in the second one. So I hope the other 26% is absolutely clear. Thank you, Zakaria. This is, wow, teaching is an art, yes. And I love when people understand what I say. It just, charges me up a lot. I'm glad everybody is on the same page here. With this, sprint 1, question 1 is done. Look at those bullet points. Understand and visualize information. See how I broke it down. I just read the question and I had this picture in my mind. I could see this red basket, this one basket with blue and red, and this other one with 16 balls I know nothing about. And then picking one ball out of each. Every time, try to, these experiments, probability and permutation combination, these feel way more connected to real life than quadratic equations or absolute values. So that is why I personally enjoy these more. You will enjoy them more if you, start to think of them this way. With this, it's time for sprint 1, question 2. Link will be up here in no time. Good luck, everyone. All right, results are here. 33% accuracy this time. Okay, so I know I have to take this nice and slow. Tell me one thing. Is it because of the sheer length of the question? Tell me here in the comments. Is it because the question was so lengthy that you got intimidated? You thought you could already feel the time pressure before you had started solving. Is that what happened? If yes, it's very important that you learn to take such stuff with comfort. Just don't read the whole thing at once. Think as if you're reading one line at a time, and that's all you have to understand. Don't scare yourself like that. That'll affect the way you think. Yes, initially, yes. Okay, so we have a lot of yeses here. Let's read this line by line, and it's going to be nice. So, a quiz game presents quizzes of progressive difficulty level to its players. So, you have D1, which is the lowest difficulty, and then D2, second lowest, and then D3. So, second lowest means the higher level, and D3 is the highest. Each quiz has 10 questions. The game is designed such that if a player answers even one of the 10 questions wrong in a certain quiz, he has to take another quiz at the same difficulty level. So you're not going to progress, you're not going to move to the next level as long as or unless you do everything correctly at a certain level. So, when a player answers all 10 questions in a quiz correctly, then he progresses to a quiz of the next level. So, this is just a story that the question has. This just told us how this system is designed, how you progress from one stage to the next. Question is, Tom starts playing this game. His probability of answering a question, so it's any question, probability of answering any question incorrectly in a D1 quiz, which is the lowest difficulty, is zero point 0.2. In a D2 quiz, 0.3. What is the probability that after taking two quizzes, he will not have progressed to D3? So we want to find the probability that he did not make it to the third stage. Now, here, let's see, let's read everything carefully. What we're given is the probability of him answering things incorrectly. So in a D1 quiz, answering a question incorrectly is zero point 0.2. So, what is the probability of answering it correctly then? You already saw how event and non-event work, right? So in my case, it has to be 1 minus zero point 0.2, which means the probability is going to be 0.8. Similarly, the probability of answering a question correctly in a D2 quiz is 1 minus zero point 0.3, which is 0.7. Now, what is it that I have to find? Understand that very carefully. I did not even go anywhere. It feels like a verbal question. Yes. Let's be very patient with this. So, there's so much you have to infer information from the question statement as you read it. Just as I said, don't think of the whole thing as one big chunk. Read a little, understand it. So, right now, I've only read the first sentence where the bold question started, and I've turned that into math, something that I understand more, something that I can see. It's just a formula. Answering correctly, zero point 0.8. You have to read question in small chunks, they'll never scare you away. With this now, let's see what to do next in this question. We already know the chances, the probability of answering any question correctly in any of these quizzes, D1 and D2. Now, what is the probability that after he does this, he will not go to the next quiz, the next stage, which is your D3? Event is he will not progress. So, how many ways are there in which he will not progress? Just see, probability, either I find the event directly that he will not progress, or I find the opposite. He will progress. And I subtract that from one. How do I make the choice? Which one is better for me? I have to see which one has fewer cases to deal with. Fewer cases to deal with. Let's see how many cases are there in each one. If I think about how he does not progress, then there are these possibilities. See, he fails twice, level D1 only, because he took two quizzes. Nobody said that the first one was D1, it was D2. He just took two quizzes. So, chances for situation one, failed D1 level twice. Second, failed D1 level first time, Second time did it properly, but even then he will not reach D3, right? Third situation, he did D1 the first time, he reached D2, but then he failed there. So even now he doesn't reach D3. So there are three cases we had to consider, we have to consider if we do this. While the flip side, the chances, the cases where he does reach D3, just one case, he passes D1, passes D2, and that's the only situation he can make it till D3. So this is how I make the decision which method to use, direct or indirect. So in my case now we have made the choice. As you see, whatever is quicker, whichever one has fewer cases to deal with, do them. Take the event where you do this forever. So here in my case, I am going to work with the non-event, which is the case that he does make it to D3. Now let's think carefully. If he does pass D1 and D2, you know the drill already. This question mark cannot scare you away. You know there has to be a multiplication because there's and. He has to get all questions correctly in each of them. Now let's find individual probabilities. First one, getting all questions of D1 correct. How did I do this? You know, every question of D1, we already know the probability of getting it correct is 0.8. So if it's 10 of them, think about it. First correct, and second correct, and third correct. There's this and I'm saying again. And that's why I'm going to multiply 0.8 with itself 10 times, which is 0.8 to the power 10. This is all about the first piece. Second piece, all questions of D2 correct. Probability was what? 0.7. So it's again 0.7 and 0.7 and 0.7. Keep multiplying them 10 times. You will get 0.7 to the power 10. And there's a multiplication option B, right? Remember that multiplication we had. You multiply these. Now here's a small rule you have for exponents. If you have the same powers, bases are different, and you're multiplying them, you can just multiply the base first and then put the power. So here zero point 0.8 times zero point 0.7 is 0.56 to the power. Remember to subtract this from 1. If you get towards the end and you say that what is it I was actually calculating, then you know under that time pressure what happens is the very first number you get, you mark it. You're so thrilled with getting a solution, getting an answer, you just mark it without checking, is this all you had to give, or was there this one little thing you still had to do? Well, here there was. You had to subtract it from 1. So the correct choice is E. Thank you, Dinesh. Shubham says you misunderstood the probability as a whole rather than each question. Yes, the question said probability of getting each question correct. With this, we're done with the first question of sprint 1. Time for third question. Link will be up here in no time. Good luck, everyone. The accuracy here, everybody check this out. It's 6%. So 94% of us got this wrong. Again, let's take this slow. Don't be scared. Nothing. It's nothing. It's all gonna come to the right stage. Let's go slow. Abe, Beth, and Carl each start to write a scientific fiction book. So each of them starts writing a book. Their individual probabilities for completing their respective books are 1 by 2, 1 by 5, 1 by 4. So it's just as if somebody starts writing a book, it's not guaranteed that that person will finish writing that book also. So here, individual probabilities are given. So Abe has 1 by 2 probability, so 50% chances of getting there, finishing it, and so on. A a completed science fiction book, once it's completed, it has 20% chance of getting published. So it's not just about you completing your book, it has to get published also. So once you complete a book, then there are 20% chances that it will get published. What is the probability that Beth or Carl, but not Abe, will get their book published? You know, the whole question is based on you understanding the event whose probability you have to find. It's B or C, but not A. They should get their book published. So here is everything we're given, nicely written point by point. It's exactly what I read. You have to find the probability that B or C, but not A, will get his or her book published. This is the event. So let's talk a little more about what this event is. Once you break it down, it'll be a breeze for you. So look here. Beth or Carl's books get published, but Abe's does not. So that but means what? It means that these two things, it's actually an and, really. We're just going into very nice English words, but coming to math, to the simple stages, it just means both things have to happen. What has to happen? First thing, B or C will get the book published and A will not. So that and means it's multiplication. I've already broken down that huge event into two pieces. I hope everybody is with me till here. Now I'll go further into them one by one. I'll just call them event 1 and event 2. The one on the left, B or C, is event 1 for me, and not A is event 2. Now, if I work with event 1, you know how OR works. You know B or C. What is it? You add individual probabilities, subtract both from there. So I have to do probability of B plus C minus both. So probability of B is what? It means the chances, the probability that B, Beth, gets her book published. Now, you know, there are two steps to that. Let's get one more step inside. Getting published means first you finish your book, then it gets published. You see how I've broken this down into two more again. Completes the book and gets it published. So here then I really have two more events that are making up this event of Beth's book being published. So if I find out the probability, you know, and is multiplication. So what is the probability, first of all, that Beth completes the book? That is given to us in the question. That is 1 by 5. And then the book gets published, 20%, which was what? 1 by 5 again. So that gives you 1 by 25. I hope you understand how we got probability of B. Now, probability of Carl's book being published. Same drill. He finishes the book and then it gets published. Finishing the book is 1 by 4. Getting published is 1 by 5. This gives you 1 by 20 for Carl. Finally, B and C. Both of them get their books published. And B and C, just multiply individual probabilities. What are the individual probabilities? The ones you just found. 1 by 25 and 1 by 20. Multiply them together. So it's 1 upon 500. When you do all of this calculation, add and subtract, you're going to get this. I hope everybody is absolutely clear with the probability for event 1. Next, I'm going into event 2, which is probability not A. That Abe does not get her book published at all. Now, how can that happen? Again, do I need to go into the non event or is the direct event quick? How do we assess that? I told you the way is to see which one has fewer cases in it. So, in my case, if I think about situations in which she does not publish, there could be this: either she does not complete the book or she completes it but doesn't get published. So there are two cases, right? She does not complete the book, she completes it but doesn't get published. What's the flip? What's the opposite? That she does get it published. Just one way that's possible. She finishes it, gets it published. So in this other case, no, it's just one case, easier. She has to do just one thing. So find the probability that A happens. That means the book gets published. So it's going to be what again? 1 by 2 for finishing the book times 1 by 5 for publishing. So that's 1 by 10 for us, right? Now you have to subtract that from 1, remember. So it's 9 by 10. This is event 2. Now finally, what did we have to start from? We started from probability of event 1 and 2. Event 1 was B or C, A was not A. So that and we already know it's multiplication. Just multiply the two numbers you just got, the two probabilities you just got, and the product shall give you the final answer 99 by 12. Now, I will not go ahead unless you tell me that you understood how this works and you understood how, yes, this was with many, many layers, but it was effective. We didn't put or and both of them together, breaking events down. It's the same thing we did, but it had many layers to it. That's what added the difficulty. But the core concept was just what you learned in the warm up. Tell me how everybody is feeling about this one. This is the end of sprint 1. With this, we'll go into sprint 2. So you have to be absolutely comfortable with this. Tell me how you're feeling about sprint 1, your warm up, your journey till here. What are the big takeaways? Yes, Sudhanshu says we got that now. All right. You forgot to subtract B and C, Kailash says that. Yes. So I told you when it's or, there's always that risk of double counting. So you have to make sure you subtract the double counted part. Isn't A or B completing the book independently? Yes, Ravish, they are doing the books independently. Absolutely. That is why we're just multiplying them. So, all right, everybody has understood this. Welcome, Ashish. It's your first time. Many more sessions with us, I hope. All right, so we're all set with this. This is the end of sprint 1. Let's all get ready for sprint 2. It's going to be 700 plus level now. Be very careful with these. First link is up here, sprint 2, question 1. Good luck, everyone. All right, the results are here, 40% accuracy. So again, it's pretty low. Before I move on, there's one thing I'd like to address. Ravish asks that B and C are independent events from the previous question. Then why do they still have an intersection? Food for thought. Independent events and mutually exclusive events, they're different things. When it's mutually exclusive, they cannot happen together. Then the intersection is zero. So search a little about that, and the recording, as Ashutosh said, will definitely help you. Dinesh, questions are difficult. They're genuinely difficult. It's just about building your concepts, being confident, and using a structured approach as we teach you. And one more time to see that would be here on this question. Let's read this together. In a business school, 4 out of every 5 students and 2 out of every 3 international students are males. So the first piece that we had was 4 out of 5, any students, just 4 out of 5. And second was when you just talk about the international students, then 2 out of 3 are males. If a student is selected at random, the probability that that student is an international student is zero point 0.3. That means from this business school, randomly pick up someone, the probability that that person is an international student is zero point 0.3. That means really 30% of the school is international students. Now, what do we have? Total number of students is 100, and 2 students are selected at random. What is the probability that at least one of them will be a female international student? At least one of them means what? Either one or both will be female international students. So before anything, let's see what all we can get from the question. So as I said, you have zero point 0.3 probability of a student being international, and total students are 100. So how many international students do you have? 30. So this is piece 1 that we get. We absolutely know the number of international students. Now focus on this flow chart. You have total students divided into 2 classes, international and others. Then within each of them, you have male and female. Now let's try to fill in whatever we can from the question into this. Right now, it's just headings. You don't know any values. So let's see what values we can fill in. So you know 100 is the total students. International also you just found is 30. So how many will be others then? That's going to be 100 minus 30. That's going to be 70. So here you see the first stage of the flow chart filled up. Now, what do I know? Read this part carefully, the blue box that just came up. 2 out of every 3 international students are males. So total international students are 30. How many are males then? 2/3 of them. So we just found 2/3 of 30, which gives us 20 males. So how many females are there then? 30 minus 20. You have 30 total international students, 20 were males, remaining are females. So we're completely done. We know exactly how the international group is formed. Now you also know one more thing, that 4 out of every 5 students are males. That's for all the students, not international, or not the people who are from that place only, from that place. So in that case, for 100 total students, you find 4/5 of them. That gives you 80 males in total. Now you already know 20 of those males are international students. So remaining 60 students are males in the others category, and therefore females are 10. I hope everybody is absolutely clear with this flowchart. Just see how that question with 4 sentences, 4 lines became so easy. Now this is so much more easy to digest. You can just see the flow chart and tell any value that you might want. In fact, those 4 lines also did not have this much. There's a lot that we inferred and put into this. Now with this, let's see where we have to go. We have to find out at least one of them will be female. Remember, you have to randomly select 2 people. And as I said, there are 2 ways, either one female or both female. So both things can happen. There are 2 cases that you have to deal with. Well, what's the flip side? The flip is just one case, no female. That means it's not a female international student. It could be anything else. anything else but not female international students. So there's just one case to deal with. So Kailash, you understood till here, didn't know how to go beyond that. Let's see, let's understand how this is working. So calculating the probability that no female international is easier than calculating the probability that you have at least one female international. So that is why I am going to work with the non-event, no female international. Now let's see, no female international students. How do we get the probability for this? Let's again use whatever we had from the question, whatever information we had. Remember, international, when we broke down, we found that the number of females there were 10. 20 were males and 30 were total, so 10 females. So female international students are 10 out of a total of 100 students. That means how many are not female international students? I'm not saying female or international. I'm saying international students that are females. You had 10 of those from 100 total people. So 90 of them are not these. So the probability of selecting two people, each of them belonging to this category, is, let's see, let's hit next. I want you to see as I speak that the probability is going to be 90 C2 over 100 C2. Remember, I talked about this in the beginning. C was combination for selection, when order did not matter. So it does not matter whether I selected female A, then female B, or B and then A. I just care about which two people I've selected. So from that group of 90 people, I have to select two, 90 C2. And total number of ways of selecting two people would be 100 C2. So that becomes your denominator. You just solve this and you get your answer here. This is, I can't see, it's a little too small, choice C after you simplified. I hope everybody is absolutely clear. There's 60% that got this wrong. You need to build up on your conceptual understanding and the way you approach questions from every question that we do. Take every question as a new thing, something that you're learning, something more that you're learning. So everybody understands now what this is going to be, how this is going to work. Thank you everybody. All right, we are ready for sprint 2, question 2. Link will be up here. Good luck everyone. All right, 80% accuracy. That's wonderful. A hard question, 700 plus level, and a data sufficiency question at the same time. Great accuracy, everyone. Let's discuss this. A box contains N shirts. I don't know the number of shirts, of which 60% are white in color. So, without knowing the total, obviously, I cannot tell what's the exact number of white shirts that I have. Three out of every four non white shirts have a tailoring defect. So take away the white shirts that you have. We're talking about the non whites now. Whatever four shirts you pick up, three out of them are going to have tailoring defect. Don't actually try to do it, it's about probability. What percentage of white shirts, the 60%, do not have a tailoring defect? Let's see how we can do this. Right now, we have no idea about the tailoring defect aspect in white shirts because the question just told us about non white. Now, look at this flowchart. Before we fill in the values, you have to understand how this is structured. So, total shirts, two parts, white, non white. And then in each of them, you have defective and no defect. Now, we'll try to fill in the values from this based on whatever we get from the question. We'll read it part by part and keep filling it in. So, let's see. First piece that we had is that there are N shirts in total, right? So the total shirts block that you have right on top, that is N. Then how many white shirts? 60% of N, which is zero point 0.6 N. And therefore, non-white is going to be what? Think about it. Total are N, white are zero point 0.6 N, subtract them, you get 0.4 N. Then you go into white defective. No idea. That's what the question is. I have to take a new variable. Now, before I move on, here's a small tip. Take a new variable only if it's absolutely necessary. In my case, if I had a way of expressing the defective shirts among the white shirts using N only, I would have done that. But my question gave me no relationship. So I had to get a new variable into the picture. So it's x for that. And so non-defective is zero point 0.6 n minus x. Now when you go into the non-white, you do have a relationship. If you didn't, you would have to take another variable y. But you have something from the question, 3 out of every 4. So 3/4 of the non-white are defective. So you find 3/4 of 0.4 n. That gives you 0.3 n. And so no defect is 0.1 n. Now, what is this thing that we've circled? This is the white no defect. Why? Why is this specially highlighted? Look at what the question is asking. White shirts that do not have a tailoring defect. So this is what you want, the 0.6 n minus x. So we've assumed, of course, you've seen the only assumption we made was the number of defective shirts among the white shirts. Now here's what you have to find out. Percentage of white shirts that don't have a tailoring defect, which means no defect over total white shirts times 100. Now, how do you decide what should be in the denominator? It's percentage of white shirts. So, whatever is after the of, that is your whole. That is what comes in the denominator. And whatever is after that, no tailoring defect. So, white shirts, obviously, because that's the group you're working with. So, white shirts with no tailoring defect, zero point 0.6 n minus x, that's in the numerator. And multiplied by 100 because you had to convert this to a percentage. Now, when you simplify this, it's this 1 minus x upon 0 0.6 n times 100. So, to get this value, all you care about is this fraction x over n. If somebody gave you that value, you'll have the answer. So, in other words, you can say you want the value of x in terms of n. Now, with this, see how on the top it's clearly written what you need to find so you don't lose sight of it. With that, statement 1 now. If one shirt is selected at random from the box, the entire box, we're not saying white, not saying non white, the probability that it will have a defect is 0.5. That means out of the total shirts that you have, the probability of some being defective is 0.5. Which means what? Which means defective shirts divided by total shirts is 0.5. Now, those defective shirts could be white, could be non white, remember. So, look at these four options, think about it. Which ones should it be? defective shirts in all. I'm not saying white, non white. So the correct one is A, which is white plus non white, both of them with defects divided by the total shirts. So in my case, how do I express that mathematically? This is going to be white defective is X, non-white defective is 0.3n, and if you add them, you will get, just give me a second. If you add them, you will get x plus 0.3n divided by n, 0.5. Simplify this, you do get x by n. That is what you wanted to find out. That's why I've written that on the top. So you can find x by n. So because of that, statement 1 is sufficient. With that, let's move to the analysis of statement 2. The probability that a shirt with a defect will be white is 2 by 5. So the probability that a shirt with a defect, that means the group that you're looking at is defective shirts. From that group, you want to talk about the probability of a shirt being white. That means it's white defective over total defective. That is equal to 2 by 5. So when you use the values that you have from the flow chart, you get this, and simplifying it, you do get x by n again. So statement 2 alone is also sufficient. That's why the answer is D. I hope the 20% of you who were confused with this are now absolutely clear. With this, we're going to the last question of the day, the last hard question. Link is up here. Good luck with it. Okay, so this was the last question. Accuracy 20%. This, yeah, was hard. This was heavily based on visualization, which is a very, very important process skill. If you can't see what's happening, then you won't be able to progress. Yes, it's not geometry, but rectangle and coordinate plane, that it has a feel of geometry, and geometry itself heavily relies on visualization. You'll learn more about this in our session next Sunday, which is on geometry, so join that to learn this skill. Now here, let's read this one. A rectangle is to be constructed in the xy plane such that the x coordinates of each vertex are integers that satisfy the inequality this. So this is some information about the x coordinates. Similarly, you have information about the y coordinates, integers from 1 to 8. One side of the rectangle is parallel to the y-axis. Okay, so it's like this. How many different rectangles can be constructed? Okay, so this is a lot of information. Without drawing some rectangles out, there's no way you can do this. I mean, if you did do this without drawing, I don't know, but it's going to be super comfortable if you do this properly. Look here, first of all, let's take this slow. So the values of y, because it's 1 through 8, 1, 2, 3, 4, 5, 6, 7, 8. And the values of x, look carefully, there's a strict less than 6. It's not less than or equal to. That means we can't include the 6. So the values of x are going to be 2, 3, 4, 5. Now with this, what I have to do is I have one more piece of information, that there's this one side of the rectangle which is a vertical line. Why? Because it's parallel to the y-axis. Since it's a rectangle, obviously the other side is going to be like this, no? A horizontal line segment which is parallel to the x-axis. So this is how my rectangle is going to be oriented. I look, this is how it's going to be. I have no idea what the vertices are, what the coordinates are, but this is how it'll look. Now I also know possible values of the coordinates, right? Now look, how many different rectangles can be constructed? Now, you might be at a loss, but see this getting more and more clear piece by piece. Look at the coordinates for A, x1, comma y1. I know nothing. I've just randomly called those coordinates x1, comma y1. Now, with this, what is it that I can get? I can get the x coordinate of D. It has to be the same as A, right? It has to be x1, and I can get the y coordinate of B, which again will be the same as that of A. So y1. Now, what happened is I don't know the complete coordinates, but I know one of the ordinates, one of them. What about C now? It's a very interesting thing. Just see, when I don't know anything about B, I had to name it something, so I called it x2, the x coordinate. Similarly, for point D, where I was just sure about the x coordinate, I had to assume something for the y coordinate, and I've called it y2. Based on this B and C, point C, sorry, B and D, point C automatically gets determined. The x coordinate same as B, x2. The y coordinate same as D, y2. So x2 comma y2 are the coordinates. So overall, you see how many values of x we have. There is x1 in point A and D. There is x2 in points B and C. So how many x values? Two x values. Think about y values now. So you have y1 in A and B, then you have y2 in C and D. Again, just two y values. So from the many values that you have for your x and y, you have to select two each. The moment you do that, you will have all four, right? So this is the principle, this is the method that you could use to break this down into a simpler state. So now I know just need two x coordinates, two y coordinates. Now look at this. Possible x coordinates are how many? Four. I know it's 2, 3, 4, 5. I have to select two out of them, out of these four. Similarly, possible y coordinates are 8. I have to select two of them. And there's an and. Why? Select two of these and select two of these. There's not a choice that I'm getting. Select two x's or select two y's. No, you have to do both things. So you multiply. Selection combination 4C2 multiplied by 8C2. You just go to your calculations, then just put in the formula for combination and permutation. Let's see what we get. You will calculate this. Yes, the answer will be 168. I hope everybody understood this. The accuracy for this was pretty low. The question, if I read it here, um, yes, so people did find this question difficult. We're looking for more practice. Yes, Ashutosh has given you links. He's told you how to practice. Follow that properly. This now is something I want to talk about. You all felt the need for more practice, for the right practice. Some person here today might be struggling with PNC. Someone else might be struggling with probability. And not when it's and, maybe that someone is struggling when it's or. How do you do that structured practice? Well, come and witness, experience this Quant 2.0 that we're bringing in, version 2 of our Quant, which is based on this expert technology. Expert, it's personalized. You work on what is important for you. Engagement is the key here. We have a lot of interactive activities. You will never feel as if you're just studying and studying. You'll have fun while you study. We'll reinforce your conceptual understanding with the right kind of practice. So you'll have tens of hundreds of questions to practice from. Then you will be able to track your progress. So you will get percentage results. So your percentage accuracy for probability is suppose 30%. You know you have to work there. Similarly, for PNC, it's 70%. You know you're better there, but you can get even more good. So this methodology, Quant 2.0, is based on this this methodology, this technology that is designed to help you succeed. The link to access this free trial is in the comment section. Ashutosh has already posted that. With this now, I want to talk about something more here. As I said, it's personalized. How do you know right in the beginning before starting what you have to do? So it's the diagnostic quiz. You diagnose yourself just how a doctor does and then work for your treatment. So diagnostic is where you start, and with the adaptive thing that we have, you will just practice the right stuff. Let's see. Next thing I want to talk to you about is Ashutosh. Let's let everybody see the slide before I start talking. Yes, as said, we bring in a lot of sessions for you. Sessions such as these that we had today, this one that we had today, to help you succeed. GMAT strategy session. So strategizing is very important when you're low on time, or when you have a lot of time but you don't know what to do. I read a comment, somebody has the exam this Friday. So right now, yes, you're very, very close to the test, but people who are still preparing, you need the right strategy so that you're ready in time. Rajat, the founder of EGMAT, is going to host this session on Saturday, 20th March, 7 a.m. PST, 7:30 p.m. IST. The link for that is again here in the comment box. So this is one session you do not want to miss. You'll be able to create your personalized study plan, giving you a method to strategically review your performance and improve with every quiz you take, every mock you take, you'll see yourself improving. The next session I want to talk to you about is this that I'm going to host on Sunday. This is on GMAT geometry. I talked about this briefly. Visualization, which you saw in action on the last question of probability today, is a key skill on geometry. That's not the only skill. There are more that you have to master, but this is very, very important. So, this session, you'll be able to understand how to visualize things, how to understand questions so that you're never at a loss. What do I do? What should I do with this information? I'm so confused. We will teach you all of that here on Sunday. Make sure you join me there and learn about common faltering points, how to solve difficult questions, and so on. Lastly, your personal plan, your personalized study plan, we can help you create that. An expert, a strategy expert from EGMAT will get on a one-to-one call with you to help you with this. This is on a first come, first serve basis. So make sure you book your call. You just have to book it, choose a slot for yourself, and you will be done. You just have to enter a few details about yourself, your target score, what you're currently doing, what you're currently scoring, and so on. So, a lot of information here I gave you. Process skills I mentioned, just talked about visualize, but I said there are more. These are 6 process skills that we were very proud of. They really help you bridge that gap between conceptual understanding and application. People know the concepts, but when it comes to questions, they're at a loss. So, this is what will help you. Find the link in the comments for this. You will get a link, a list of all videos, many videos to help you understand the importance of process skills. Next, let's see. Video lessons, as I said, they'll be there. Concluding remarks. I'm going to sign off in a very short while. Ensure you have 200% clarity. I said this right after our warm up as well. You need to solve questions step by step. Don't take any shortcuts. They don't work every time. Some questions they might work, in other questions you'll get stuck. Become an active reader of the question statement. You saw that today also. You have to be absolutely careful, very into the question, very aware of every piece written there. Trust the test maker. He's not going to ask you something that you don't know, something out of the whole thing completely. He's not going to ask you the binomial theorem, for example. Believe in your skills then. You're trusting the test maker, trust yourself also. When you prepare so much, trust that you have everything in your arsenal to help you succeed. With the right attitude, you will succeed. Good luck, everyone. Thank you for joining us today. This was a nicely attended session. I hope everybody liked it. See you next time, Sunday. Thank you.